In this episode, we're going to take a very normal-looking shell script problem and treat it like a mystery you can actually solve, because the first time it happens it feels unfair. A script works perfectly with a simple file name like notes.txt, and then it suddenly breaks when the file name is my notes.txt, or when a folder name has a space, or when data has commas or tabs in it. That failure is not random, and it is not because the shell is fragile for no reason. It happens because the shell has rules about how it splits text into pieces, and those rules are easy to trigger without realizing you did anything special. Once you understand what the rules are, you can write scripts that behave predictably even when the input is messy, and that reliability is a big part of being comfortable around Linux automation. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good way to start is to separate two ideas that beginners often blur together: text as humans see it, and tokens as the shell sees them. When you look at a line of text, your brain might treat a space as just a visual separator, like a pause in a sentence. The shell, on the other hand, often treats certain characters as boundaries that break one string into multiple pieces, and it does that before your script logic really gets to decide. That means a value that you thought of as one thing can silently become two or three things, and then everything downstream shifts. If your script expects one argument but receives three, you might see errors that look unrelated, like a file not found or a command complaining about extra parameters. This is the root of the classic spaces problem. The script is not seeing one file name. It is seeing several words. This token splitting is strongly connected to a setting called internal field separator, IFS. Think of IFS as the set of characters the shell uses when it decides where one field ends and the next begins, especially during certain expansions. By default, IFS usually includes spaces, tabs, and new lines, which means the most common whitespace characters can become splitting points. That default is convenient when you actually want to separate fields on whitespace, like when reading a simple list of names, but it becomes dangerous when whitespace is part of the data. The tricky part is that you do not always notice when splitting has happened because the script still runs, just with different pieces than you intended. Understanding that IFS exists and that it influences how the shell interprets text during expansion is one of the first big steps toward writing scripts that do not surprise you later. A closely related idea is output field separator, OFS, which comes up in other contexts and in other languages, but it helps to keep the mental model simple. Separators matter both when you break input apart and when you join output back together. In shell scripting, you often build output lines that combine multiple values, and you may rely on spaces or other separators without thinking about them. If your output will later become someone else's input, like a report parsed by another tool, then your choice of separator is not just cosmetic. When beginners say a script broke on spaces, sometimes what really happened is that a script produced output with ambiguous separators, and then another step split it differently than expected. So while IFS is usually the star of the spaces problem, it is useful to hold the bigger picture. Scripts are constantly turning streams of text into fields and fields back into text, and separators are the rules of that game. Now let's bring functions into this, because functions are where the problem becomes easier to manage instead of harder. A function in a shell script is a named block of logic that you can call like a mini command. Without functions, scripts often become long chains of lines where variables get reused, modified, and passed around in a way that is hard to reason about. With functions, you can isolate a behavior, decide exactly what inputs it accepts, and decide exactly what output it produces. That isolation is especially helpful for handling tricky data like strings with spaces, because you can enforce safe patterns at the boundaries. In other words, functions are not just a style choice. They are a control mechanism that lets you define rules for how your script treats arguments and text. If you adopt the habit that every function protects its inputs and returns predictable output, you will naturally avoid many of the accidental splitting problems. A key concept for safe function design is that the function should treat its inputs as data, not as a command line that needs to be reinterpreted. In shell scripting, you often pass information into a function as arguments, and the shell assigns them to positional parameters inside that function. If you handle those positional parameters carefully, you can keep each argument intact even when it contains white space. The dangerous habit is to combine things into one unquoted string and then expect the shell to put them back together correctly later. Once data has been split, it is difficult to reliably reconstruct because the original boundaries are gone. A safer habit is to keep values in their own variables and pass them through function calls in a way that preserves their identity as a single argument. This is one of those moments where it helps to think like a parser designer. If the boundaries matter, you must preserve them from the start. The most practical way to preserve boundaries in shell scripts is to quote variable expansions in the places where splitting would hurt you. The shell has a difference between a variable name and its expanded value, and the expanded value can be subject to splitting and pattern matching depending on how you use it. When you surround a variable expansion with quotes, you are telling the shell to treat the result as one unit, even if it contains spaces, tabs, or other separator characters. Beginners sometimes think quoting is about making something look nice, but it is really about controlling evaluation rules. If you do not quote a variable expansion that represents a file name, a path, user input, or any data you did not personally craft to be space-free, you are essentially rolling the dice. Reliable scripts are not scripts that never see messy input. They are scripts that handle messy input without changing their meaning. Where IFS becomes especially visible is when your script reads lines of text and tries to break them into pieces. Many scripts read from files, from system output, or from user-provided data, and then iterate over the results. If the script assumes fields are separated by spaces, it may work for a simple dataset and fail as soon as a value includes a space. Some learners try to fix this by changing IFS globally, and while that can work in a carefully controlled script, it can also create new surprises because it changes how later expansions behave. A more disciplined approach is to scope changes to IFS as narrowly as possible, ideally in the smallest region of code that needs custom splitting. Functions help here because you can set IFS inside a function for one specific parsing task and then return to defaults when the function ends. That is not just neatness, it is a risk reduction technique. Another way to make scripts more predictable is to choose separators that are less likely to appear in real data. Spaces are extremely common, so using a space as a field separator is often a weak assumption unless you control the data format. If you have the option to use a delimiter like a tab, a comma, or a pipe character, you can sometimes reduce ambiguity. However, you should not blindly assume those characters never appear either, because real-world data can contain almost anything. The better idea is to choose a delimiter based on the format you are consuming and producing, and then handle it deliberately. When you know the delimiter, you can set IFS to that delimiter only for the parsing step that needs it. You can also design your function outputs so they are easy to consume safely, like outputting one value per line when possible, which avoids the entire question of splitting on spaces. It is also important to understand that splitting and pattern matching can come as a pair. If you expand an unquoted variable, the shell may not only split it into multiple pieces, it may also treat certain characters as patterns that match file names, which can cause unexpected extra values to appear. This is one reason why a script might behave differently depending on what files exist in the current directory, even though the script code did not change. To a beginner, that feels like the script is haunted, but it is just the shell applying its normal expansion rules. Quoting prevents that second class of surprise as well, because quoted expansions are treated as literal text rather than as patterns to be expanded. So when we say scripts break on spaces, the deeper truth is that scripts break on uncontrolled evaluation, and spaces are simply the most common trigger that reveals the problem. Functions also give you a clean way to validate assumptions. If a function expects a path, you can check that the input exists and is the type you expect, like a file or directory, before continuing. That kind of validation is not only about catching errors early, it is also about narrowing the search when something goes wrong. If the function receives 3 arguments instead of 1 because of splitting, the validation can catch that immediately and stop with a clear message, rather than letting the rest of the script stumble onward. That makes debugging far easier, especially for beginners who are still learning how to reason about script flow. In a well-structured script, You can treat unexpected argument counts as a sign that splitting or quoting rules were violated somewhere, and then fix the real cause instead of chasing symptoms. A related best practice is to make functions do one thing and do it consistently, including having a clear relationship between inputs and outputs. If a function produces output that other parts of the script will consume, try to make that output easy to parse safely. For example, if the function returns a single value, it can output exactly that value and nothing else, with no extra commentary, so the caller can treat it as data. If the function needs to return multiple values, the safest design is often to output them in a format that preserves boundaries clearly, such as separate lines, or a delimiter you have deliberately chosen and documented in your own script. That is where the OFS mindset matters, because joining values into one string without a safe separator is how you create future splitting problems. The more your functions behave like reliable building blocks, the less your script depends on fragile text tricks. One misconception that causes trouble is the idea that you can fix spaces problems by simply removing spaces from file names or by telling users not to include spaces. That may work in a controlled environment, but it is not realistic in a general-purpose Linux environment, especially when scripts touch user directories, downloaded files, shared storage, or data exported from other systems. Another misconception is that spaces are the only issue, when the true issue is that any delimiter character can cause incorrect field splitting if you rely on defaults. Tabs, new lines, and even characters like commas or colons can all cause similar issues depending on the parsing approach. A strong script is built on the assumption that input can be messy and inconsistent, and that your job is to interpret it safely, not to demand that the world behave perfectly. That mindset shifts you from hoping a script works to knowing why it will work. To tie everything together, remember that shell scripts are, at their core, text processors that also launch programs, and the boundary between text and structure is where many bugs live. IFS influences how the shell turns text into fields, and careless expansion can silently reshape your data. Functions give you a way to create safe borders, where you accept arguments, validate them, and handle them in a controlled way so the rest of the script can trust what it is working with. The combination of careful quoting, deliberate parsing, and scoped use of separators is what makes scripts survive file names with spaces, log lines with mixed formatting, and user input that does not fit your assumptions. Once you internalize that, you stop treating spaces as a special enemy and start treating them as a normal part of data that your script is designed to handle. That confidence is the point, because reliability in scripts is not about cleverness. It is about understanding evaluation rules and designing around them.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.